In the previous video, we created a very basic texture plugin inside the lab. And now I want to extend this a little bit by creating something a little more useful and interesting to look at. So what I had in mind for this tutorial is to be able to create a texture map which can take an external mesh, and then it can give you a white value wherever the points are inside that mesh, and it's going to give you black values when the points are outside of that mesh. So for example, if I create a plane here, which is probably the easiest thing to demonstrate this with, and we can later substitute it with some other mesh. And if I also create a sphere, right now, the whole texture should be black because all the points on the plane are outside of the sphere. But what I want to do is create a texture that when the sphere moves like this through the plane, I want the outlines of the sphere, whichever points appear inside the sphere, I want them to turn black. So to do this, I will obviously need my position, and I will also need the sphere as the input. And I forgot to mention in the previous video, but both the position and the normal inputs that you have in texture coordinates are actually world space coordinates. They're not local to this plane object, they're actually world space coordinates, so you do not need to multiply them by anything extra when you do your calculations. Let me rename my input to a mesh input, and I'm going to change its type to polygon mesh so that we can accept the sphere as one of the inputs. And I'm just going to select the sphere, so don't forget to do this later on. Along with the sphere, we will also need to take the sphere's world coordinate transform, because all of the points inside the sphere mesh are currently in object coordinates, and we need to get a way of getting these points to appear in the same coordinate system as our surface position. So if I click on the mesh and add a component input, I can now add a transformation input, and transformation will give me an xform3 value, which is a transformation from sphere's object coordinates into sphere's, or rather into world coordinates. And what I want to do is take the coordinate that I have here, the surface position, on top of my mesh to which a texture is applied, and I want to bring it into the same coordinate system as the sphere. So I'm going to take this mesh xform, I'm going to drag it out to get the type value for my transform, and then in the list of outputs I can find the inverse property, and this is what we will use. So basically we want to multiply. I'm going to add a multiply node, and it's going to be multiply alternative 2, which allows you to multiply transformations by vectors. And as the transformation, I'm going to select the inverse, and this is inverse because originally, remember, we have our object to world coordinate, and the inverse will give us the opposite, the world into object coordinates. And the surface position is in world coordinates, so this will bring it into the sphere's object coordinates. So now we also will create a object called polygon mesh projected grid. And from a previous tutorial, you can remember that this is basically a utility class which allows you to take a mesh and do operations like determining whether a point is inside of it or measuring a distance to a mesh. As the mesh, I'm going to provide my input. I just changed the bin count to 10, but this can be any other value, and it's just an internal calculation value that we shouldn't be concerned with in this video. And next thing I'm going to do is get the type value for this projected grid object, and inside of this I can see that there is a output called isInside, and this is a function which accepts a coordinate, and then as a result it provides a Boolean output, and the output is going to be true whenever this coordinate is located inside the mesh, and it's going to be false otherwise. So I'm just going to take my coordinate which I have pre-computed and place it as the coordinate input for this method. And now I'm going to also create an if node. And the reason I'm doing this is because I want to produce different outputs depending on whether a point is inside the mesh or not. So if it's inside, if the value is true, I'm going to output 1. And if the value is false, I'm going to output 0. And as my condition, I will take this condition of whether a point is inside the mesh or not. I'm just going to wire this here. So the output is going to be a floating point. It's going to be either this or this, depending on this output of this tester. And I can just drag this output into the graph's output, and now I have my texture. I can assign this texture to my plane. And let me just make the sphere transparent for a second so that we can see where it changes. So I'm just going to change the opacity to 0, and I'm going to move it a little bit so it overlaps the actual plane. We can see that stuff changes here. Unfortunately, we cannot preview it at the moment inside the viewport due to the fact that when rendering bitmaps for viewport, we do not really get all this extra information such as surface position and mesh. But if I hit my preview render, we can now see that whatever the sphere intersects our plane is actually turning white. And if I move the sphere a little bit higher, we can see that this cross section changes. And this can really be any object. So this can be a teapot or whatever, but for now let's stick with the sphere. And just to be a little bit more adventurous, let's take our plane and add some more segments to it. Let's say add 40 by 40. And then also create a displacement modifier on top of it. And as a map, we're just going to take our lab texture, which we have just created, and I'm going to drop it into the map slot here, and I'm going to instance it. And let's create some kind of offset value. So if I take my plane, if I take my sphere, I can now see that as I move it over the plane, we actually get a nice displacement offset going on here. So just to prove that this works on any mesh, I'm going to take to create a teapot object, just like we did create a sphere, and I'm going to substitute the sphere for a teapot. So I'm going to select my teapot as the new mesh. Now I can see that there is already some kind of offset going on the plane wherever the teapot appears to be. And if we assign the transparent texture to this, we can see that the teapot is actually being part of the texture, which we can render and see the cross section of this teapot. So this is a nice little introduction into textures. I hope to make more videos about this in the future. This is it for now.